Okay, in 10.3, we talk about some more identities, starting with the double angle identity. So we've got the three double angle identities up here, and then of course remember that cosine has got a few variations when we use the Pythagorean theorem. So we can replace cosine squared with 1 minus sine squared, and we can replace sine squared with 1 minus cosine squared, and that gives us the two other versions. Okay, but really if you remember the first line, you're usually pretty good. All right, so there's our three identities. If you don't have those written down, you probably want to go ahead and pause right now and write them down so that you have them with you for when we go through the next problem. Okay, so let's say that we're given a value, such as cosine theta equals 7 over 25, and we know that sine theta is negative. And we want to find the values for cosine 2 theta, sine 2 theta, and tangent 2 theta. Okay, now that's not just, you can't just double what we're given because that wouldn't be the same thing. We're trying to double the angle and then find the sine, cosine, and tangent. Okay, so what we're going to do, you can either solve this using the Pythagorean theorem to get your sine value, or you can set up a triangle. So either way is fine. I'll go ahead and set up a triangle. If we've got cosine positive and sine negative, that means we've got to be in the fourth quadrant. And here's our theta. And we know that cosine is 7 over 25, so that's adjacent over hypotenuse. Okay, so 7, so I can write that a little bit better. 7 over 25. Okay, and then we're going to use Pythagorean theorem to find the missing side, which would be our y. So we're going to have 7 squared plus y squared is equal to 25 squared. And you work that out, you get 49 plus y squared is equal to 625. And then we get that 49 over there. And we should get y squared is equal to 476. And then when we take the square root, sorry, that's 576. I knew that didn't look right. Let's back that up. 576. Okay, and then when we take the square root on both sides, the square root of that is going to be equal to 24. And we've got to keep in mind that we are in the fourth quadrant. Okay, so it's the square root is plus or minus 24, and we're going to take the negative root because we're in the fourth quadrant. So this side is going to be negative 24. So if you set this up as sine squared plus cosine squared equals 1, it'd kind of be the same thing with fractions, and you have to remember to take the negative root because sine's got to come out negative. Okay, so we're given that cosine is 7 over 25. We found one way or another that sine is equal to negative 24 over 25. And then you can do tangent as sine over cosine, or you can read it off your triangle. We're going to have negative 24 over 7. Okay, so either Pythagorean theorem or using a triangle. Okay, so now we've got our values for theta. So now let's work on getting our values for 2 theta. So let's look at cosine 2 theta first, and we remember from our formula sheet that we could write that as cosine squared theta minus sine squared theta. And we can put in, now we can put in our values for theta. So cosine squared would be 7 over 25 squared. And sine squared would be negative 24 over 25 squared. So we're going to have 49 over 625 minus, and this is going to come out positive now, we're going to have 576 over 625. And so that's going to be equal to 527 over 625. And that's not going to reduce because 625 is, all the factors are 5. So that's going to be our final answer there for cosine 2 theta. All right, let's see if we can fit in sine 2 theta. I think we can. Okay, so sine 2 theta is 2 sine theta cosine theta. All right, so we're going to have 2 times negative 24 over 25 times cosine, which would be 7 over 25. Okay, so on top, we multiply that out, and we should get 336 over 625. And again, 625 is all factors of 5. So there's our sine 2 theta. All right, we're going to need a little bit more room for tangent 2 theta. So let me erase what we have going on over here. I'm going to leave our Okay, so I erased our work over here, so we got a little bit more room to work, and I left our cosine sine tangent values. So let's see if I can fit it in here. So we're going to do tangent of 2 theta now, and looking at back at our formula, it's 2 tangent theta over 1 minus tangent theta squared. So 2 tangent theta over 1 minus tangent squared theta. Sorry, 2. Okay, so I made some space over here and kept our cosine sine tangent values. So now let's do tangent of 2 theta up here. Oh, somehow I got rainbow colors here. I don't know how I did that. Alright, so the formula tells us to do 2 tangent theta over 1 minus tangent squared theta. Okay, so we'll put the formula up there. And so that's going to give us 2 times negative 24 over 7 over 1 minus negative 24 over 7 squared. Okay, so that's going to give us negative 48 over 7 on top over, and this is going to be 1 minus, and this is going to come out positive, 576 over 49 here. Okay, so this is all one big fraction here. So let's simplify the bottom first before we try to do multiplying by the reciprocal. So we're going to have 48 over 7 on top still. And the bottom we're going to have, I'm going to change this right here to 49 over 49 so that I have a common denominator. So I'm going to have 49 minus 576, and that's going to give me, oh, that's the 527 again. Okay, so negative 527 over 49. Okay, and now we can change this to multiplying by the reciprocal. So negative over negative is going to come out positive. We're going to have 48 over 7 times, and then we're going to flip this, and we're going to get 49 over 527. The 7 and the 49 can cancel, make this a little bit easier before we try to multiply out. And then we're going to have 48 times 7 is going to come out to, sorry, that's my puppy dog, 336 over 527. Okay, so there's our tangent value. And then remember also that you could do tangent of 2 theta is equal to sine 2 theta over cosine 2 theta. So since we already had sine and cosine 2 theta, we could have done sine 2 theta over cosine 2 theta, and we would have gotten the same answer. I apologize. Our cosine 2 theta should have been negative up here. I left off that negative. Okay, so you can either use tangent 2 theta using the formula, or you can, if you have sine and cosine already figured out, you could do sine over cosine as well.